All right, hello everybody. Today we are going to be learning about how we can use the calculators to write linear regressions. Okay, so first let's look at the do now. It says when factored completely, very key word there, the expression is equivalent to. So remember, whenever your problem says completely, that means you're going to have to use factoring more than once. So factor more than once. So I'm looking at my expression here. We have p to the fourth minus 81. So I notice that there are two terms, and oh my goodness, I noticed there are two terms, and we have perfect squares because 81 is a perfect square, and to the fourth power, any even exponent is a perfect square. We also have subtraction in between, so that's everything that tells us we need to use dots. Okay, so to use dots, we set up our two sets of parentheses. One gets a plus, one gets a minus. To figure out what goes inside of them, we take the square root. So the square root of p to the fourth is equal to p squared. So remember, a little trick is just to divide that exponent by 2. And the square root of 81 is 9. So p was in the front, so it stays in the front. P squared, and 81 was the second term, so it stays as the second term. 9 and 9. Now we look to see if we could do anything again. Looking at this first parentheses here, we have two terms, but we have a plus sign, so we can't use dots again. There is no GCF, so this one is done. Nothing we could do there. But this one, we have two terms, a subtraction symbol, and we can use dots again because we still have two perfect squares. So remember, this stays the same, so I'm just going to write it down as is. But for this second one, we can use dots again. So for dots, we have the two parentheses. One gets a plus, one gets a minus. The square root of p squared is p. The square root of 9 is 3. So p goes in the front, and 3 is the second term. So now let's see which one of these is our answer, and it looks like it's going to be answer choice 3. Notice when we were at this step here, that answer is right over here. That's to trick you, okay? So remember, when it says factor completely, you have to factor more than once. Okay, so going on to regression. So the first thing we're going to talk about is the correlation coefficient. The correlation coefficient is a number that tells us how well our line fits. So the correlation coefficient is called R. That's the symbol for it. It's a number between -1 and 1. So if you have a line like this, notice the points are very close together, okay? This is a positive correlation. It's positive because the lines are going up, okay? Now this correlation, these points are so close together, it looks like they form a line. That tells us that the R is 1. Okay, so the closest you get to 1, or the closest your points are to forming a line, your correlation coefficient is 1. So let's look at this second one. In this second one, the points are a little bit further away, but you can still see that they're going in an upward line. Okay, so it looks like they're going up. That is also an example of a positive correlation. Now, these points are not as close together as these are. That tells us that R is further away from 1, but they're still kind of close, so it's about 0.5. Okay, so it's moderate. If you have an R as 1, this is a strong correlation. If you have somewhere in the middle, it's a moderate correlation. Now let's look at the other examples. So here, this line is now going in a downwards direction. Remember, we always read graphs from left to right. That's how I can tell if they're going up or down. Since this is going down, that's what we call a negative correlation. Now, when it goes down, R is going to be a negative value. So here, since the points are really, really close together, they look like they form a line, R would be 1. Let's look at the next example. Again, they're a little bit further apart, but it still looks like they form a line. Looks like we can kind of fit a line in the middle there, but it's still going down. Since it still is going down, our correlation is still negative. But since they still look like they form a line, we still have a correlation coefficient. It's going to be negative because it's going down. But since they're not perfectly set up in a line, R would be about 0.5. So again, this would be a strong correlation, and this would still be a moderate. Now looking at this last one over here, I don't know what's going on. I don't know where I would fit a line in this mess of dots. So when you have a situation like that, that's when you have no correlation. That means that your points don't look like they create a line at all. When that happens, your R is 0. Because they have no correlation, they do not make a line. So this is just kind of a little recap. When R is close to 1 or negative 1, that is a strong correlation. For example, if you have an R that equals 0.8 or an R that equals negative 0.9d7, whatever it is, if it's close to 1 or negative 1, that's going to be a strong correlation. When R is close to 0, okay, so let's say you have an R that equals 0.1 or an R that equals negative 0.2. That is a weak correlation because I'm going to turn back for a second. The closer you are to 0, the more of a mess it looks like. The closer you are to 1, the more of a line it looks like. Okay, so moving on. Let's look at an example. So here it says, which is the relationship between the independent and dependent variables in the scatter plot below? So here we're looking at correlation. If we look at this mess of dots, it kind of looks like it's going in an upward position. Okay, so that means it's going to be positive since it's going up. So I can get rid of 3. Now, this also does kind of look like a line. Since it looks like a line and not just a mess of dots. Oh, I'm sorry. I don't know why I just crossed out 3. I meant to cross out 2. It can't be 2 because it's not negative. Since this kind of looks like a line and doesn't look like a mess of dots, there's clearly a correlation there. So it can't be no correlation and it can't be undefined. So it's going to be 3, a positive correlation. Okay, so the scatter plot below represents the relationship between the peanuts a student eats and the student's bowling scores. Which conclusion about the scatter plot is valid? So keep in mind that this is the number of peanuts a student eats and bowling score. Just thinking about that, that really shouldn't have anything to do with each other. But let's look. So it says there's almost no relationship between eating peanuts and bowling score. Okay, let's just keep that there. Students who eat more peanuts have higher bowling scores. I don't see any type of positive line here. I just see a mess of dots. If this was the case, our line would have been like this. Straight up. I don't see that. So 2 is out. Okay, then it says students who eat more peanuts have a lower bowling scores. That would also have to mean that there is some correlation here and the line would have to be going down in a negative way. But again, I don't see that here. I just see a mess of dots. 4 says no bowlers eat peanuts. Well, clearly some bowlers are eating peanuts because it's written here. So that's out. So the answer is 1. There's no relationship between eating peanuts and bowling scores. There is no correlation here. Okay? Now, we're also going to be looking at finding a line of best fit. To do this, we must use the calculator. You have to, you can't get away from this. Okay? So here are the calculator steps if you want to pause the video, write this down, or take a picture. So I'm going to move forward, and we're going to look at an example. So it says the table below shows the number of grams of carbohydrates, X, and the number of calories, Y, of 6 different foods. Write the linear regression equation, I'm going to underline that, for these data points. Round all values to the nearest hundredths. Whenever a question says write the linear regression equation, the only way you could do it is with your calculator. So I'm going to go to my calculator, I'm going to press Stat. I'm going to go to Edit, and now I have L1, L2. If there's something in there, scroll up, press Clear, and scroll down. That's how you get rid of the points that are in your column. Now what we're going to do is we are going to type the data points that are in this table into L1 and L2. So these points here are going to go into L1, and these are going to go into L2. So X is in L1, Y is in L2. So we have 8, 9.5, 10, 6, 7, and 4. Those are all our X values. Now we scroll over to L2 and put the corresponding Y values. So 120, 138, 147, 88, 108, and 62. Notice they end at the same point. They should. If you have one extra value in either column, this won't work, and you have to check if you typed it in your calculator correctly. Okay, so once you have everything in L1 and L2, you go to Stat. We're going to scroll over to Calc, and you're going to scroll down to 4, which is Lin Reg. So enter. Keep pressing enter until you reach calculate. And this is what you come up with. Now, there's something that we are missing on our calculator. This means that our diagnostic is not on, and I'm going to show you how I know that. So we're all going to turn our diagnostic on together. So press second 0, which is the catalog, and you're going to scroll down to D. Okay, another way to do it is you can click where D is, and it'll bring you to the first one. So you're going to scroll, scroll, scroll. Now here it says diagnostic on. You press enter, and you press enter again. It should say done. So once you have that, go back to Stat, go back to Calc, and go back to Lin Reg. Press enter again until you reach calculate. Now notice it gave us some more information. What was different is before it only gave us A and B. Now we have R squared and R. Remember, R represents our correlation coefficient, so you want that there to see how good of a line this is. So let's get to writing the equation. So we have y equals. Notice here it says ax plus b. That's pretty much the equation of a line, right? We learned it as y equals mx plus b. It's the same thing. Now they give us what to plug in for a and what to plug in for b. All the information's there. All we have to do is round it. We want to round it to the nearest hundredths. So first let's start with a. Hundredths is 2 decimal places. So the second decimal place is this 1, and it stays a 1 because the number next to it is below 5. So this is 14.11 x plus, here's our b. We're rounding it to the nearest hundredth, which is where this 3 is, and it's going to stay a 3 because this 3 is below a 5. So plus 5.83. and that's our equation. In the second part, so part B, it says state the correlation coefficient. The correlation coefficient is R. It is not R squared, okay? That is a different value that we are not going to be dealing with. It is just R. So here, why don't we round, I don't know, doesn't say where to round. Why don't we round to the 7, okay? So the thousandths place. So if we round to that 7, we get 0.99. That 7 will round up because this number is above a 5, so 998 if we were to round it. It says, does R indicate a strong relationship? Yes. R indicate, yes, R indicates a strong relationship because it is close to 1. Okay, it didn't say to explain, but I want to explain just because it's our first time really seeing a problem like this. Now let's do part D. It says using your equation, so I'm going to stop right there. Using our equation, this is our equation. So I'm going to start by writing that down. Y equals 14.11x plus 5.83. Okay, determine how many calories are in a food that contains 15 carbohydrates. I look back at our tables. Carbohydrates are where X is. So that means X represents the number of carbohydrates. So if we're looking for 15 carbohydrates, this tells us that X equals 15. So what we have to do is plug in 15 for X. So to do that, we have 14.11 times 15 plus 5.83. Gonna go to the calculator. 14.11 times 15 plus 5.83. Enter, and we get that value, 217.48, and in this case, that represents calories. Okay. All right, so we finished that question, so let's go on to the next. Emma recently purchased a new car. She decided to keep track of how many gallons of gas she used on 5 of her business trips. The results are shown in the table below. Write the linear regression equation, so we're using our calculator for these data points. Round all values to the nearest hundredths. So here are our data points. Nothing is labeled X and Y, but first column is usually going to be our X. The second column will be our Y. So going back to the calculator to do this, first we have to go to Stat. We have to put in our values, so we go to Edit. There's values in there. To clear it out, scroll up to L1 or L2. Press Clear, and then scroll down. I can't emphasize this enough. If you press delete, you will mess up your calculator. Don't do it. Press clear and go down. All right? So now let's type in our values. We have 150, 200, 400, 600, 1,000. In the second column, we have 7, 10, 19, 29, and 51. So our two columns line up. That's a good sign. So let's go to lin reg. So press the stat button again. I do want to draw attention to us using the stat button. Stat is short for statistics. We're in our statistics unit. That's why we're using this button a lot. So scroll over to calc. We're going to lin reg because we're doing a linear regression. Don't confuse this with number 8. We're working with number 4. Press enter. Enter all the way through. And here we have all of our values. So we have y equals ax plus b. Let's fill in our values. So y is equal to, it tells us that this is a, 0.0513179916. Well, we're not writing all that down. It says round to the nearest hundredth. Hundredth is the second decimal point, so it's where this 5 is. It's going to stay a 5 because 1 is less than 5. So it's 0.05 x, don't forget your x. B is a negative number, so instead of plus, we're actually going to put a minus in this one. Now let's round it. We round it to the nearest hundredth, which is the second, so it will be a2. So the equation is y equals 0.05 x minus 0.92. And that is our equation, because that's all it asks for. Write the equation. All right, moving on. Here we have number 5, where it says a nutritionist collected information about different brands of beef hot dogs. She made a table showing the number of calories and the amount of sodium in each hot dog. Write the correlation coefficient for the line of best fit. Write your answer to the nearest hundredth. Correlation coefficient is what we spoke about in the beginning. It is our R value. Explain what the correlation coefficient suggests in the context of this problem. Okay? So, let's go back. Correlation coefficient, go to stat, go to edit. We have to type in our values in our table. So clear everything out, and we type them in. 186, 181, 176, 149, 184, 190, 158, 139. Go to L2, and I have 495, 477, 425, 322, 482, 587, 322. Okay, let's say that I'm done here. I go to stat, go to calc, go to 4, enter, 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 enter. Oh no, I have an issue. What happened? So, whenever you get this message, it'll say quit or go to. I'm going to say go to my mistake. What did I do wrong, right? So it's saying that there was something wrong in L1 and L2. So let's see. Look what I did here. These two are different. The reason being is look at our data. I forgot 370. That's fine. Just fix it now. So I'm just going to type in 370 instead of 322. And then type in 322, okay? So if you ever get that error message, just make sure to go back to your columns to see if you typed it incorrect. So go to calc, go to 4, enter, 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 and this is what I get. So there's two parts of this problem, part A and part B. So part A is just to write the correlation coefficient. So the correlation coefficient is R, not R squared, which is right here. We're rounding to the nearest hundredth, which is the second decimal point. This is going to stay a 4 because this 2 is below 5. So R is 0.94. Okay, now part B says, explain what the correlation coefficient suggests in the context of this problem. What you should always do for these types of problems is first say, is it strong, is it weak, is it positive, or is it negative? So we're going to start with that. So the correlation coefficient is 0.94. that means there is a strong positive correlation between, and then let's write our 2 points. Our first is calories, and our second is milligrams of sodium. So there's a strong positive correlation between calories of a hot dog. Now I'm getting hungry. And milligrams of sodium. Okay. All right. Now, since I know not all of you have the calculator, whether you have it on the app, on your phone, I'm going to show you how to use Delta Math for it. So your Delta Math page looks like this. Again, this is your regular calculator button. So when it pops up, a normal calculator comes. We're not going to be using that. Press the arrow, go to a statistics calculator because we are using statistics. You type your data into L1 and L2. You go to Calc menu, and you go to Lin Reg. This one here where it says AX plus B. You are going to turn your diagnostic on. Diagnostic helps you find that correlation coefficient, and then you will press calculate. I'm not going to do this because I didn't type anything into L1 or L2, but once you do that, you will use these steps. Okay, so going on to the practice. So here are the 3 practice questions you have to do for this lesson. Make sure you do this on a separate piece of paper and then upload your work to Google Classroom. Have a great day, guys.